All right, so here we go, chapter 12. Now, the bell is going to ring. The bell will ring before we're done with this one, okay? So you're going to have to watch the end of this video online, okay? We don't get out of here at 50 or something like that? I do not think I can get through it. Okay, so the whole thing of statistics is you have a lot of people, okay? Let's talk about all of the students of Mineral Wells High School. Okay, and I can sit here for a long time, and I think there's 840 of you about, give or take a few, right? Whole bunch of people. And we want to know something about you guys. Thanks, sir. Okay, and so, but I don't want to ask every single person the same question. Okay, so what I'm going to do is I'm going to take a small group of you. We're going to call that a sample. And this is the population. Population's everybody. If you were making paper clips, if you worked in a store making paper clips, your population is all the paper clips that you can make. You don't want to look at every single paper clip, but you better look at some of them once in a while. Okay, so populations do not have to be people; they can be things. We're going to take a sample from them. From that sample, we're going to take a statistic. Okay. Well, what's their average height? What's their average, whatever it might be. Okay. Okay. We're good. And from that statistic, then we're going to use inference to talk about the parameter of the population. So I'm going to take some of the kids from the high school. I'm going to see how tall they are. Then I'm going to take their average. Okay? And their average height. And then I'm going to say, oh, guess what? The kids in our high school are average this height. Do they average that height? I have no idea. But my sample averaged that height. So I'm going to use my sample to, it's called inference. We've talked about that somewhere in your life, I'm sure. Okay? But populations have parameters, samples have statistics. Okay, so this is the process of statistics. All right. So how are you going to get that? How are you going to take that sample? This first lesson is how are you going to take that sample? And once you take the sample, what are you going to do with all that data? Right? Just a bunch of numbers. Nobody wants to see numbers. So we're going to try to make the numbers look good. All right. So when you're at a party, how can you tell the statisticians from the accountants? The music's bumping. How do you know the accountants and the statisticians? How do you tell the difference between them? The statisticians will look at your shoes. Okay, so both of these are very boring types of people go in to be a statistician or an accountant, and so statisticians look down at accountants. Accountants just look at their own shoes. The statisticians, we're fun people. We'll look at your shoes in a party. Both shy people. Okay, there you go. All right. So if we have a set, remember we've talked a little bit about set, S-E-T. Okay, it's everybody is the population, and then a sample would be a subset. So basically, from chapter, what is that? When did we do set? Is that chapter 3? Chapter 2? One of those two. Anyway, this is about the only, let's put this all together stuff. All right. So here we go. What's the population of this one? The board members of a homeowners association. Do you know what a homeowners association is? It means everybody in the neighborhood has the same type of house, and they all give money, and somebody takes care of the front and takes care of the pool, and they all can use the gym and the pool and all that kind of stuff. Okay. All right. So they want to know their opinions because they want some new paint colors. So what's the population? 300. Where'd you get 300? All right. So they want to know the paint color choices from every single homeowner in their association. So it's every homeowner in their association. But let's say this is a big place and there's 1,000 homes. Do you think they really want to go to 1,000 homes and say, which colors do you like better? No. Okay, so this is why we'll take a sample from them. A city government wants to conduct a survey among the city's homeless. Okay? To discover their opinions about city shelters. Okay? Who's the population here? What about the non-homeless people? Do they count? No. Because look what they want. They want to know the homeless people's opinions. So every homeless person in the world, the state, in the country, in this particular city. All right, so be specific when you do this. All right, ready? How are we going to get this? How are we going to get this from them? All right, what we want to do is take a sample. The first way is a random sample. I'm going to tell you this is not the easiest way, but it's the best way. And basically it says everybody has an equal chance to be in the sample. If I would take a sample of our high school, and if it's run to be random, then every single person has an equal chance. That means the DAEP kid has an equal chance. The kid that's just a punk has an equal chance. The little freshman, the kid that won't talk, the kid that does drugs, the super athlete, do we have one of those? Oh yeah, okay. We have one. That's all it takes. High school, one is good. So you see what I'm saying? So everybody gets an equal chance. Now, when the Dr. Funk made up a principal's council or something, advisory board, do you think it was a random sample?
No.
No.
What they did was they asked teachers and said, represent what student that would be good for this.
Yes. So it was. So you are not you don't represent the school. Do you understand that? There's a big difference. You do not represent the school. All right. All right. We wish you did. We wish you were our representatives. All right. So what you're looking for is a thing that is a representative sample. Okay? That means that you have short kids and tall kids, and you have athletes, and you have band, and you have drill team, and you have cheerleaders, and you have slackers, and you have stoners, and you have skateboarders, and you have people who do absolutely nothing at the school, and you have people that are troublemakers, and you have people that go perfectly what they're supposed to do. You have people who skip school, you have people that go DAP. That would be a representative sample, and it's hard to get that. It really is. Most people don't want it. So here's one way that the homeowners did. Okay, so there's 250 houses in their neighborhood. They don't want to ask them. So what they did is they numbered every house, gave them a number between 1 and 250, and then randomly chose 25. There are random number generators on the internet, on calculators. It's easy. This is easy to randomly pick 20. Let the calculator randomly pick 25 numbers between 1 and 250, and then you can go to those 25 houses and ask their opinion. And the deal is that should, if done correctly, should be a representative sample. Okay, so So this is B, yes. Should be.
Why
Okay?
would that be a random sample? Just a random.
That's you got to have somehow. You have to introduce randomness somehow. You don't get to pick which 25 houses you get to go to, because if you're the homeowners association person and you're at the clubhouse, who are you going to talk to? You're going to talk to the people that are in the clubhouse that day, and then you're going to go down the road and go to your friend's house and get their opinion, and that's not a representative sample. Okay, so here we go. Ready? Group of homeowners in a large city. Okay, think. I know some of you are from Rayford. Okay, so Mineral Wells is not a large city, so think Fort Worth here. Okay, so we want to know what they think about casino gambling. So the population would be no, everyone in the city. Every single person in the city of Fort Worth. There's about 500,000. You don't think there's 500,000 people in? It's over 500,000. Yeah. Yeah, it's a big city. All right, it is. We can look it up. All right. So one of the hotel owners says, "Hey, why don't we go to the 6 biggest nightclubs on a Saturday night and ask them what their opinion of casino gambling is?" Is that a representative sample?
No, because you're almost ready to go out and play.
Right. So
So
people who frequent nightclubs may differ from the rest of the city. So think of who goes to nightclubs. Probably people in their 20s, right? Maybe a few 30s, and then just a few creepy old dudes. Yes. So where are the 40 and 50-year-olds? Not at nightclubs. They're at their kids' ball games. They're working. They're whatever. They're a little more responsible in life, a little bit. What about the senior adults? And so all these people have different ideas. So this is not a representative sample. All right. So here's what we did in our town. I don't know if you knew this or not, but we want to know what's the biggest problems of our city? So the population is people of Mineral Wells. Okay, so the city inserted a survey into the water bills. I got one at my house, and if you live inside the city limits, your family got one as well. Okay, and they asked everybody to return them. It was 4 pages long, this survey.
You did?
Heck no, I didn't do it. And I don't know why I don't have it. Because I thought I kept it to show you guys how bad it was. Okay. All right. Is this a representative sample?
Yes.
No. Who responds to surveys? People who are mad at the city. So everybody else, like if you're fine with the city, you just throw it away. So, or if you love the city, then you filled it out and said, "Oh, I give you 10 out of 10, 10 out of 10, 10 out of 10." So, not everyone will respond. Usually, only negative people. I'm going to say that as nice as I can. Okay. People who complain. All right. Next one's on the test. My test. All right. So one thing. If I ask all 840 students of Mineral Wells High School a question, I no longer have a sample. I just did a census. And the federal government, by law, has to take one every 10 years. And so they just finished theirs. All right. So I'm going to continue recording. It's about, well, it's quite a bit. So you're going to have to watch Yeah, it's going to take me probably 20 more minutes. Okay, so it's going to be a long video. So if you're watching this video, we're only about halfway done. All right, go Rams. Let's win homecoming.
Win today.
All right, so you finally get all the data. You collect it all. And basically, you have a bunch of numbers. So let's say we wanted to ask how many siblings you had. Well, we asked the first person, they have 2. Next one has 4. Next one has 0. Next one has 1. Next one has 3. Next one has 7. You know? And so all we have is a list of numbers. And that's boring, okay? So what we want to do is do something with this list of numbers. We don't want to, no one wants to see a bunch of numbers, okay? And so with so here's what people confuse them. After data have been collected, they seem like that's misspelt or the grammar's wrong, but data is plural, okay? And so after data has been collected is what you want to say, but it's not. Data is plural, so that has to be the correct verb. And so, yes, data are plural. All right, so here we go. Here is some data that we collected for a certain week. And so what the first thing that you would do, and this is going to be not too big of a deal, but you make a frequency table. And you've done this many times in your life, okay? So this is not very difficult. So the low number was a 65, and then a 66, then a 67, 68, and that seems the highest, okay? And then you just make tally marks, so 68, 65, a 68, a 66, a 65, a 67, and a 68. And so this is 2, 1, 1, 3. Piece of cake. You got this. Frequency tables. They're really boring. They're really, really boring. But they're okay. So there's a distinction in your homework that might confuse you. Data items. Okay, so these are the data items, and the data values, or I think they call those things. Okay, so yeah, I think that's pretty much correct. Be careful when they use those two words, that you don't think data values are these, or data items are these. So frequency tables are easy. You can do it this way: A, B, C, D, F. What grades do we get? I mean, you've done this so many times in your life, I'm sure. I'm not going to tally marks to these things. I'm just going to count them. 1, 2, 3. Those 3 A's. 1, 2, 3, 4, 5 B's. 1, 2, 3, 4, 5, 6, 7, 8, 9 C's. 1, 2 D's, and 1 F. Okay, so I didn't think I got that on there. I just did the whole problem without having the video on. Sorry. So here we go. There's that. Okay. Frequency tables, piece of cake. Nice and easy. So in these notes, chapter 12 notes, I put some nice good jokes in there. That's funny. Okay, so we're going to use the following data to make different types of graphs. Okay, so the first one that we're going to do is, well, if you notice that there's not enough of these. So what we're going to do is make intervals. They're going to call them classes. And we're going to see how many are in this class. So what's the lowest number we got here? We got a 58, 52. Find the lowest. I don't think anything's lower than 50. Oh, there's a 41. So that seems like the lowest. So 41 is the low. And the high, we got a 90, 96. But there's no 3-digit numbers, right? We've got a comma there. Okay, so there's no 3-digit number, so let's go high of like 99. And I'm thinking that we'd go 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay? So sometimes you don't have, these don't have to be single values, they can be intervals. Okay? And we didn't go 40 to 50, 50 to 60, because then which one would you put the 50 in? So a 50 is going to go in this second row. And then we can just make frequencies of these things. So let's see here. This is going to be difficult to do. I think I'll tally mark these things back here. So 70, 58, 68, 75, 91, 79, 96. There's a good chance I'm going to miss one here. 87, 82, 89, 52, 99, 97, 89. These are smart kids, they sit together. 58, 95, 77, 75, 81, 75, 73, 73, 62, 69, 76, 77, 71, 50, 57, 41, 98, 77, 71, 69, 90, and a 75. Woo! So I got 1, 5, 4, 15, 5, and 7. Still not real enjoyable to do, but it's doable. Okay? Alright, so the class width here, they're going to ask you about that. So class width is equal to 10. Okay, so because 50 minus 40 is 10. Okay, so you do class width min minus min of each interval. Okay, so that's, make sure you do that one. You can also do max minus max, it gets the same number. And what else are they going to ask you? Oh, they're going to say, they're going to call this in the first class, second class, third class. So there's that's weird notation to me. So if they say what is the min of the third class, well, you're going to say 60. Or what's the frequency of the third class? That'd be 4. Okay, so that's just a little helpful hints. The biggest deal is that these could be intervals. All right, now we're going to use this data from this chart to make some pictures. Okay, so here we go. First one up is called a histogram. And I'm trying to get this centered so we can get it nice on here. All right, so make histogram. First thing is you have yourself an x-axis, okay, and I'm going to put 40, 50, 60, 70, 80, 90, 100. Okay, and then I'll make a y-axis, and my y-axis is going to be frequency, so this is test scores, and this is going to be frequency. And if you remember, the biggest number was 15, so my y-axis has to go up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's good. And then what you do is you draw little rectangles. So in the 40, it went up, 40 to 50, it went up to 1. There's only 1. Make a rectangle. 50 to 59 went up to 5. Make a little rectangle. 60 to 69, 60 to 70 there. 70 to 80, went all the way up to 15, and then this one was 5, and this one was 7. Okay, histogram. Woohoo! Okay. You can put test scores up here. Test scores, and put some more detail if you need to. Okay, so the histogram is done. Now, what if we put a dot in the middle of every single one of them? Don't do this, okay? Do not do this, okay? And then we erased the boxes. Well, I kind of set it up to do that already, okay? So you kind of got to think, okay, there could be a bar right here and a bar right here. And what you do is you make this, you connect the dots, and those are just the maximums of each class. And that is what they call a frequency polygon. I'm not a big fan of the frequency polygon, but I'm sure they have their, I understand it. There's a lot of scores in the 70s and 80s. When I look at this, I see lots of scores in the 70s and 80s, which is what I see here. Lots of scores in the 70s and 80s. One kid didn't do so well. A couple kids didn't do so well. Some kids did really well. Okay, so that's a frequency polygon, and I believe that you go outside the classes to get that last point, because there's nobody in the 30 to 40, and there's nobody over 100. So, all right, that's just for help for homework. And the one that's going to be on my test, and the one that's going to be on the final, and the one that you got to know how to do, definitely, is called a stem and leaf plot. Okay? And so, stem and leaf plot, we start with the lowest score, and it is a 40. And I think you've done stem and leaf plot. It's in the 40s. You've done stem and leaf plot somewhere in your life, possibly. Okay? And then there's some scores in the 50s. There's scores in the 60s. There's some scores in the 70s. There's 80s. And then there's 90s. So we need a, make sure I'm on screen here. All right. We need a title, which is test scores. Okay. And then we're going to go through the data. So the first one was a 73. You see a 73 and then a 58. So we're going to go 73, 58. And eventually we'll get a little key over here. 5/8 is a 58. Okay. 68 was the next one. 75. So here's the second one. 75. 91. 79. 96. 79. 87. 82. 89. 52, 99, 97, 89, 58, 95, 77, 75, 81, 75, 73, 73, 62, 69, 76, 77, 71, 50, 57, 41, 98, 77, 71, another 69, 90, and 75. Alright, so I just did that data. And there's my stem and leaf plot. Okay? And if you notice, you just do like this, bloop, 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 bloop. You can almost picture a histogram on that thing. What if these are rectangles and you would see histograms? Okay? The benefit of a stem and leaf over a histogram is a stem and leaf preserves the actual data values. Okay, I can actually see, oh, someone scored an 82 with a histogram. Let's see if I can find the histogram paper. The histogram, I don't know somebody scored an 82. I just know how many people scored in the 80s. So 5 people scored in the 80s, but with a stem and leaf, I can see that someone scored an 82. Now, if, here's a little statement. If a leaf gets too big, split the stem. Split the stem. Now I'm going to show you how to do that as well. So this leaf is pretty big, right? So what we're going to do is we're going to split the stem. So here we're going to do this whole thing again, but we're going to split stems. And the top stem will be 40 to 44. This one will be 45 to 49, 50 to 54. Okay, so this maybe might make it a nicer looking graph. So I got a 41, which goes right there. I got a 58, a 52, another 58, a 50, and a 57. I have a 68, a 62, a 69, a 69. I have a 73, a 75, a 79, 79, 77, 75, 75, 73, 3, 6, 7, 1, 7, 1, 5. I have 82 and an 81. I have an 87, 89, 89. I have a 91. 96, 99, 7, 5, 8, 0. Okay, so this is the same exact data values. So here's the original. Okay, our eyes are definitely taken to this long leaf, and then we come here, and maybe you can notice something that this person really scored. This person's pretty far away from everybody else, right? So that's troublesome. Everybody else seems to be fairly close to each other, but a lot of people in the high 70s. Lots of people in the high 70s, which is probably okay. You can definitely recover from a high 70s to still make an A. So you can also make circle plots. We're not going to do those. Pie charts, whatever they're called. We're not going to do that. Okay, so as we finish this one up, it's probably more than you wanted to know. Okay, and the last part of your homework on 12.1 is things that can go wrong. But the 3 rules of statistics going to be on my test. Ready? Make a picture. Make a picture. Make a picture. Make a picture, make a picture, make a picture, make a picture, make a picture. No one wants to read a bunch of numbers. Nobody. Make a picture. Americans don't want to read my numbers. They want to see pretty pictures. That's why Instagram works. Okay? However, when you make a picture, there's a lot of things that can go wrong. Here's some things that can go wrong. As you work through the homework, you might want to review some of those things that can go wrong. Okay? So, People do deceiving things all the time. Make sure they all have a title. Watch out for misleading scales. Okay? So, ask yourself, should the scale start where they started it? Okay? Some people are a little deceiving when they do this. Okay? Watch the design. Are there too many pictures? Okay? A graph should just tell a story and that's it. Stop. Do not make too many pictures. Trying to be fancy. Okay? Using pictures instead of bars. That's what people. Oh, sorry. Using pictures instead of bars. I think I have an example of this that I can find quickly. All right. So here's who died in the Titanic. Okay, first class, second class, third class, the crew. Okay, but what about this graph right here? Okay, so they used pictures, and it actually two dimensions, right? It got longer, but it also got higher. So now the crew looks like it's 20 times bigger than these, or five times bigger than that. But in reality, it's just like double that. So pictures could be deceiving. There's a website called Bad Graphs, and you can go there and you can just look at all the horrible graphs people do. Watch out for time on the horizontal axis. Okay, because things change throughout time, and so you can't. They just seem to be unreliable when you have time. Just be careful. Okay, the bar sizes need to be the same, and you should have some type of source. Okay, just because somebody put a graph out there doesn't mean it's right. Make sure they have some type of source from a real study, a real sample that they actually done. That they have done. Okay, and I believe that is the end of 12.1. So a lot of stuff in 12.1, and when you get to the end of your homework in 12.1, it's questions like, what's wrong with this graph? Make sure you work on those, okay? Because some of those questions are going to come up on my test. All right, that's it for 12.1.